Okay, next we'll look at how we can increment and decrement a pointer. Now using the addition and subtraction operators plus and minus, and including the plus equals and minus equals operators, or using the increment and decrement operators plus plus and minus minus, we can apply an offset to a pointer. An offset is calculated as n times the size of some type, such as an integer, for example. So I explained that previously, so whereas in the previous section we did not change what the pointer points at, incrementing or decrementing the pointer will actually change the address in the pointer. Right, here I have a quick demo array. I have these few elements in the array. I have a pointer which I'll initialize to this address of the demo array, and then I'll do some offset. So I'll do ptr is equal to, so I'm changing using the assignment operator and changing the address stored in the pointer. I do ptr plus 2, so that's going to do an offset of 2, or in other words 8 bytes. So we should get 6 now, so 0, 1, 2. Let's go. Okay, so I'll go and dereference that, build and run, and we get 6 printed out. So why I emphasize the fact that this is a change and not a temporary calculation is if I use the subscript notation like this, and before I build and run, this here is the same as this, of course. So this is the same as ptr is equal to ptr plus 2. Then I change this here to ptr using the subscript operator, and I specify index 0. And you can think for a second where the problem comes in here, because we've changed pointer. At a quick glance you might think that this is going to return 2, but it's actually not, because remember we've changed what the pointer points at. So we'll actually get 6, as you might have expected. Now of course this is similar to doing ptr. So ptr plus 0, and then we dereference that. So I explained that in the previous sections. We'll get 6. So that is why you can just go and dereference it like this. You can also use the increment operator on that. Control F5. That'll give us 4. So initially it pointed to 2, so that first element. We do the increment here. So it'll essentially move to the next element, so 4 bytes on, since this is an integer. And of course the next element in this array is 4. You can actually do something like this when you initialize the pointer as well. So let's say ptr, and we do demo array plus 2. Build and run that, and you'll see we get 6 once again. So this will also apply an offset. So this expression will then essentially return an address which we store in the pointer. Okay, so just something else here out of interest. I have these 2 pointers. Now I can essentially determine the offset between these 2 pointers. I'll actually just go and rename that, and then I'll print out n right here, where n is the offset, of course. I'll just call that offset. Build and run that once more, and we get 2. Let's do that again, maybe. Something like that. And you'll see the offset here is 3. 3 times 4 will give us 12 bytes of offset. Right, so I hope you found this interesting, and I'll see you in the next section. So in this section I just want to explain briefly about the difference between the types. So between a pointer and an array. We have talked about it to a certain extent in the previous video. Mainly the relationship between the two, so I have a pointer for example, and some array identifier, let's say demo array. Now an array is often described as a constant pointer or an alias for a constant pointer, and that may be one way of explaining it, but I prefer to keep these things separate, the idea of a pointer and array, because it can get a bit confusing. We can dereference that pointer. Actually that is pointer 1, yeah. So we've talked about these things before. We can dereference a pointer, we can get the address, so where the actual variable, that pointer variable, is stored. So we can do that. And that is going to be different than the address. So the value in that pointer is going to be different than the address of the pointer itself, so where the pointer is located. Okay, so we understand that as well at this point. You can see those addresses are not the same. And we can also dereference using the array identifier, so demo array. I'm not using a subscript operator or anything like that. I'm simply dereferencing that. And then I can build and run. And that works as well. Alright, but what happens if I do this? I'll just go and delete this actually. So here I'm trying to get the address of that demo array. So if that is a variable in memory, a pointer variable, then this should be fine. It should return an address, and then we should be able to store that in the pointer. But here if I hover over this squealy, because we get an error here, it says a value of type, and then we have this weird type. We have int, and then between parentheses we have an asterisk. Then we have the subscript operator with a 3 in there. And because the asterisk is between parentheses, you can read this type as a pointer to an array of integers. Now that's important because you also have an array of pointers to integers, so your array can actually store pointers, which of course is not what we are doing in this case. In this case, our array simply stores integers. So once again, this type is a pointer to an array of integers. Can be assigned to an entity of type pointer to an int. This is a pointer to an int, and the demo array is, well, an array, right? So the point is there's a difference between these types. And what's going to happen in some instances, so let's say where we do the assignment here using the assignment operator, or I'll just undo a couple of times, or in this case, so where we dereference it, what it's going to do is it's going to return a constant pointer. So that is why in the slides in the previous videos and some of my explanations, I mentioned that in these contexts will essentially return a constant pointer to the array. So essentially the array names are converted to pointers. A term often used for this is decaying. So these array identifiers decay to pointers. So in both of these instances, for example, so when you do the assignment or the dereferencing, but let's do something else. And I'll do the size of demo array, and we'll get 12. That is 3 integers, so 4 bytes each. That'll give us 12 bytes. So in this example, it's not going to return the size of a pointer, because that'll be smaller. It'll be like 4. Here I'll do the size of the pointer, and that once again will give us something like 4 bytes. The size of the array is simply not the same thing. So we print out 2, then we get the size of the pointer, which will give us 4, and then the size of the array will give us 12 bytes. So that pointer variable in memory is only 4 bytes, regardless of what it points at, right? It can point to some huge array. That's not going to change the size of the pointer variable itself. Whereas if you do the size of that array, you can see that is a much bigger chunk of memory. And in this instance, it also does not decay to a pointer. So I wanted to show you the differences between these two types. So it's not exactly the same thing, okay? And it's not always going to give you a pointer back. For the most part, it will give you a pointer back, right? But in some cases, so when you do the size of, or when you do the address of, use it in this instance, then it will not decay to a pointer, and then we'll get a mismatch with the types. So just try and separate those things out. A pointer is a pointer, and an array is an array. Okay, those are separate types, even though in some instances, to make your life easier as a programmer, you do have the functionality for these arrays to essentially decay to pointers. Okay, so I hope that makes sense. We've covered quite a lot in this video, but I hope you find it interesting. We won't always be using these things, but it's important to know about it because other programmers may use it, and it's important to have a solid understanding of pointers. Okay, so we're spending a lot of time on pointers in this lesson. Alright, so I'll see you in the next video.